Okay, so we've talked a little bit about volume of a cone. So now we're going to look at kind of the surface area and how that kind of goes together. So the volume of a cone is much like the volume of its cylinder cousin, but how do we find its surface area? So the surface area of a cone is going to be much like the surface area of a pyramid, where we find the area of the base plus everything wrapped around the middle. So the surface area of the pyramid, here we can see, we've got our formula highlighter here, area of the base plus the perimeter of the base times the slant height. Okay, and then we divide it by 2 because of the triangular shape or triangular nature. So since a cone is just a pyramid with a circular base, we can substitute the circle formulas for the base. So the area of the base would be pi r squared. We'll do that. And the, dang it, I am having nothing but problems today. I'll tell you. So there we go. Area of the base would be pi r squared, and the perimeter of the base would be our 2 pi r. So we're going to substitute that in. We can see that we've done that. Area of the base, we plugged in our pi r squared. Perimeter of the base, we plugged in our 2 pi r. We've kept the slant height, notice, and we've kept our divided by 2, so nothing has changed there. And again, just looking at this, our radius here is our r, and our slant height, there we have our L in green. But we can simplify this because there is a 2 in the numerator and a 2 in the denominator. So the formula can simplify to just pi r squared and then pi r times the slant height, or even more so, we can say it's just pi r squared plus pi r L. So kind of a simple way to write that formula without having to do a whole lot of work. So we have two formulas now for a cone. We have the surface area, pi r squared plus pi r L. So the radius and the slant height are all we need. And then we have the volume formula, which is pi r squared times the height. And we're dividing by 3 because there are 3 cones that fit into one cylinder. So when we look at this, finding surface area and volume of each cone, leaving our answer in terms of pi. So one thing you just have to be careful with is what information do you need? So if we look first here to find our surface area formula says we need pi r squared plus pi r L. So we can see, looking in this problem, we can see that our radius is 12. So we have pi times 12 squared plus pi times 12 times the slant height. And here's the problem. Do we know the slant height of this cone? And we do not. However, we have our handy dandy Pythagorean theorem. We can come up with that slant height. We can find the hypotenuse of that triangle. We've done this a whole bunch, and in fact, we've done this exact problem a whole bunch. So that should make this a little bit easier. So if we try to work this out, 5 squared is 25, 12 squared is 144. We can add that together, and then we can square root, and that gives us our C value is equal to 13. Or our slant height would be 13 in this problem. So a couple of ways that we can look at that, just using our Pythagorean theorem. Now, if we're going to leave this in terms of pi, this is really just a simplification problem. We have our 12 squared, that would be 144 pi. We have 12 times 13, that is going to be 156 pi. And then we would add them together. So our surface area, kind of ran out of room there, would be 300 pi feet squared. So that's how we do our surface area formula. Just for a quick reiteration then, finding our volume formula was pi times the radius, which in our case is 12. Oops, come on. 12 squared times the height. Now what is the height of this pyramid? Our height is 5. So be careful that we're using the correct values as we go through this. So our 12 squared, so this is again just doing some quick math then. 12 squared is 144 times 5 would be 720. and then we have to divide that by 3. And so 720 divided by 3 would give us 240 pi feet, and this is volume, so this is now to the third power. Now you're not on your homework going to have to do both of these on every problem, but this way you can see how we do them, how they are similar and different. They use some of the same values and some different values. So just so you can see some versions of each. Okay, so it's really just a quick formula. If you've got those, if you write them down, you can pause me obviously and write these down, and it should make it a lot easier to just do these. So, but the big thing is that you're using the right values from the picture. So for example, in this one, we need to know what the radius is. We do not have the radius of this cone. We have the height and the slant height, but not the radius. So we could say a squared plus b squared equals c squared. The 17 is the hypotenuse, and so it has to go by itself. So this is a situation where we have evaluating this out, we're going to have to do some subtraction of that 225 of that 15 squared, and that gives us 64. And so then we can square root. So we've seen, I'm kind of talking over the process because we've seen this so many times. So our radius now we have is 8, and now that we know the radius, this is a really simple formula for our surface area. We're going to do pi times the radius squared plus pi times the radius times the slant height, and in this case that would be 17. So just doing a couple of quick multiplications here, 8 squared is 64, and 8 times 17 is 136. And if we add them together, then that gives us 200 pi. They don't always work out like this with whole numbers with zeros like that, but it's just, these are the ones that we ended up using. So your volume formula then is even easier. Pi times the radius, so 8 again, squared, times the height, which is now inside the cone, 15 divided by 3. So we have 8 squared is 64 again. 64 times 15 gives me 960 pi, and then divided by 3, which would give me 320 pi inches cubed because it is the volume. So these go real quick. Biggest thing is make sure you have the units that you need. So one more just as a quick little example then. Hopefully I'm not going too terribly fast. We need the radius. So in this case, our radius would be half of the diameter. So our radius here would be 6. We don't have the height, and we do have the slant height. So if we were just doing our surface area, this would be pretty quick and easy. Our surface area formula would be pi times our radius squared plus pi times our radius times our slant height. So this would be 36 pi plus 60 pi, which gives us 96 pi centimeters squared. That one was super fast because you had everything you needed. The volume though, we do not have the height. We know that our radius is 6, and we do not have the height of this cone. We need to figure that out. So, but we do know that the hypotenuse, or the slant height, is 10. So here we could do our a squared plus b squared equals c squared. So 6 squared plus our height squared equals 10 squared. Some of you might recognize this triangle as a duplicate of a triangle that we've used quite a bit. Our 3, 4, 5 triangle, if we double it, it gives us a 6, 8, 10 triangle. So there's our height, and now we can plug that into our volume formula. So pi times our radius squared times our height divided by 3. So 36 times 8, so 6 squared is our 36. 36 times 8 would give us 288 pi divided by 3. And I know that this is going to reduce because I had a 6 in the original problem. So I know this will divide by 3, and that actually puts me at 96 pi. And we are on centimeters cubed for that. And this is an interesting situation when our surface area and our volume are the same values, but they are not the same units. So surface area is centimeters squared, while volume is our centimeters cubed. So it looks like the same amount, but we're talking about square units versus cube units, paper versus water, basically. They are different things. So paper being surface area wrapping around the cone, water being what's filling the cone up. So that's just our real quick demonstration of how to do those. So hopefully you'll be able to work through those. I will also submit the paper copy of these so you have something to look at and refer to for your completion of your homework. So good luck, and let me know if you have any questions.